This is the Tesoro AI podcast with Darius Gant. AI is changing the world and fast. This episode is coming to you courtesy of Tesoro AI, the #1 recruiting service for software development and AI talent.
All right, hey, welcome to the show. Appreciate you taking some time out to join us.
Yeah, no worries. Thanks for, I know that we had to reschedule this a little bit, but glad to be here.
Hey, it happens, you know. But would love to kick things off with you, just learning more about your background professionally, how you kind of got into this world of AI.
Yeah, so funny enough, I was not always in AI. Before this, I was actually in the medical field. So I was a nurse, transitioned out of that, got into cybersecurity. I was a hacker for a little bit, and then most recently started a company, Frenos, which is an AI native OT security posture management platform. And ever since, kind of like, I guess it was probably about like 6 years ago, I started really diving deeper into AI, machine learning models, large language models, and actually just so happens that like the spawn of ChatGPT allowed us at Frenos to do what we do.
Yeah, so that's one of the things I love about ChatGPT itself. It's like it made it a household name. Now we can have conversations about AI, whereas before it was like the realm of like the nerdy kids, right?
Yeah.
But I want to unpack your story a little bit, right? You talked about from nurse to hacker. How
Yeah.
does that transition happen?
Well, so I grew up in New Hampshire, and coming out of high school, I wanted to do one of two things. I either want to be in computers or I wanted to go into the medical field. And at that time, I don't know if you recall the show House MD. It was a doctor show.
Oh, Dr. House.
Yeah, Dr.
That was an
House.
awesome show. I love that one.
Exactly. So that swayed my decision 100%. I'm like,
Okay.
you know what? I'm gonna go become a doctor or something like that. And started working in nursing homes and dementia and long-term care, because that's kind of everything up in New Hampshire. There's only, a couple hospitals to work at. So there's just a lot of long-term care. And unfortunately and unfortunately, my specialty was in Alzheimer's. Got burnt out of that completely. Didn't like working, the 16-hour shifts, 4 days a week. So went back to school, learned a little bit more about computers, more than I already knew. And then quickly found myself in consulting. So I was a penetration tester, doing consulting for a financial institution in Boston. And then from there, I kind of, I was hacker for a while, transitioned, realized that I kind of wanted to start working in startups. So I worked at a company called Security Matters, which was an OT security monitoring solution for operational technology. For
OT, what's the acronym?
Yeah, operational technology.
Okay.
So we have informational technology, IT. We have operational technology, which is OT. So the way that I like to say it is IT manages data and information. OT manages the manipulation of physical properties. So if you think about like an electric utility, like, whoever is running the power where you're located, there are things called relays and RTACs that control the power of the electricity through the wire and whatnot. That's all operational technology. So I've been focused in operational technology, cybersecurity for a little over a decade now. And then halfway through that, started working with AI really at my time at Dragos, which was another network security monitoring platform. I was a director of R&D over there. We started messing around with machine learning models and whatnot to perform anomaly detection.
Okay.
And then I really cut my chops completely when I worked at AWS Security, where we built user behavior analytics utilizing machine learning models to detect adversaries impersonating employees.
Okay. Interesting. So that's some good backgrounds. At what point did you see an opportunity to go out and launch what is now Frenos? But I'm curious the pain point you saw, where it's kind of the second part of the question. What's the pain point? And then, why was artificial intelligence the right solution to approach this with?
Yeah, so I've been trying to build the Frenos platform for the past 6 years now. Yeah, 7 years now. The pain point is in operational technology, we have so many vulnerabilities, we have so many alerts, and we want to move the needle for our security program. A lot of the pain point is I don't know what I don't know, and I don't know where to start. And how AI solves all of that for us is we're able to utilize machine learning models to do predictive analytics on risk based scoring and whatnot. And then we utilize large language models themselves to translate all of this data input that we gather from the customer's environment and put it in a way that's actually human readable, human digestible, and available to anybody. You don't need a PhD to run the Frenos platform. You could be an intern or a junior engineer running it and still understand and get value out of that. And that's the purpose of that large language model.
Yeah. Historically, what was the solution to this, right? Like you mentioned alerts, a bunch of alerts coming through. How were folks determining what was a real alert versus false alert? What needed attention now versus later?
There was no solution. I mean, your solution was throwing more manpower at it, right? That's how some of these organizations have huge cybersecurity, security operation centers and whatnot, because their whole goal is just to look at all the alerts, look at everything, and try to figure out and suss the noise out, right? But with artificial intelligence, large language models, and machine learning models, what we're able to do is really cut through that noise, right? You don't need to worry about X, Y, or Z. A lot of what we're doing at Frenos is attack path analysis. So we are emulating or simulating how an adversary operates inside a digital twin. And we've actually named our reasoning agent, named her Syra, personified our AI agent. And her whole goal is to chain weaknesses together, utilizing certain techniques, tactics, and procedures that hackers do, or chaining vulnerabilities together to try and, we'll say, shut down the substation or turn off a safety system in the oil refinery. And we do all this in a digital twin, right? So we kind of let an AI loose on a network replica of what the customer environment looks like, which is really neat because it can just do anything it wants. There's no impact on production. It can break, tear down the walls if it wanted to. And then what we do is, just because of that LLM, we're able to take all of those individual steps that Syra utilizes and chain together and put it in a way that people understand.
Yeah. What I was visualizing when you said that is, the way that agents pop up, whether you're using like Manus or ChatGPT's agent, right? It creates this virtual environment where, yes, it's actually clicking through things, but it's purely virtual. Actions are
Right.
happening, activity is happening, but it's actually virtual. And you can go about using your actual machine as you normally would.
Right. Exactly. Yeah. And that's kind of something that's important, for operational technology. And the reason why we went down the digital twin route is because, you have to keep the power grid up. You need to keep running water, gut flowing. So you can't let loose an AI agent on an actual production system.
So what does this mean in terms of the solution itself? So is it built to be more preventative, or is it built to resolve existing issues? So if there is an attack, we're going in there, we're resolving the alert, or are we trying to create, or using this digital twin to emulate what an attacker does? And now you can be proactive about, how you build up your defense mechanisms.
The whole purpose of it is to be more proactive. We already have intrusion detection systems catching how hackers might be inside your network. The whole purpose of this is to be proactive. And that's why we utilize a lot of machine learning models to do predictive analysis.
Got it. Got it. Okay, that makes a lot of sense. What about, when I was investing, we looked at a lot of cybersecurity companies, and I think data analytics, things of that issue were important at the time. But then you've got these 0-day attacks. I believe I'm using the right terminology.
Yeah.
How do you
You're
think
good.
about where you kind of don't have, you know what I mean? Like, you don't have data on what the attack might look like.
Well, so that's the reason why we're simulating pretty much what we call the art of the possible. So we take in all this information from your existing environment, your
Mhm.
asset and vulnerability information, your segmentation information from like your firewalls and whatnot, building up this digital twin to simulate any and all possible ways a hacker could operate inside that environment. And then from there, stack ranking, utilizing an LLM to stack rank what you should be worried about now, what's more likely right now versus less likely later on to start, moving that cybersecurity needle and to increase your security posture.
Okay. Okay. That makes sense. So basically, the AI is acting as like a hacker that may be creating new attacks, and you're trying to predict where, kind of what a future attack might look like. And you mentioned anomaly detection. Is that kind of like where you're looking at the system and you're saying, you know what, this is something we haven't seen before? Let's try to get ahead of this because while it may be benign, we still haven't seen this kind of activity. So, let's hit the brakes.
Yeah, so I utilize anomaly detection in one of my past lives, my prior jobs.
Okay.
But that the anomaly detection itself is something that can feed into our platform. If anomaly detection, if some sort of, we'll say Dragos or Nozomi has some sort of alert, we can put it inside the platform and we can simulate if this alert were true, if a hacker did hack this, asset, what could be the problem, you know?
Right.
And then help our customers eliminate and cut down those attack paths.
Okay. Yeah, I've always found these ways to get to an answer using AI pretty interesting. I remember looking at a manufacturing example where you could use like supervised learning to feed an AI model examples of something being broken, right? Or
Yep.
you could use anomaly detection to say, hey, this looks weird, right? Stop the belt, right? Let's examine that before we actually do run into a scenario. So it's interesting to see these different approaches to, in your case, preventing any damage to the system. So as you thought about, I know you have a hacker background yourself, but relative to what we saw from a software perspective and how software teams were built, and I guess even cybersecurity companies were built, knowing that you wanted to use AI, were there some initial steps that you needed to take compared to if we were just looking at a traditional solution, traditional software solution?
Yeah, so there was quite a few, I guess, compensating controls we needed to implement. One, our large language model, because it has access to the digital twin, it has access to all these attack paths that might be inside your environment. We
Mhm.
actually gated the LLM, so you cannot talk to our large language model. The large language model itself, all it does is translates data into human readable input. So that was
Okay.
one. Yep,
The
that was
user can't
one.
talk.
Yep, the user cannot talk to the LLM because you think about it, the Frenos platform is keys to the kingdom, right? It tells
Mhm.
you how to attack something, where to go, what assets that are vulnerable. So if we had, if somebody that had unauthorized access to the platform could just chat with the LLM, they could
Right.
extract so much data, so much information to further their attack inside that customer's environment. So that was one big key feature that we had to implement was nobody talks to the large language model.
That's interesting. That's interesting. So basically, the LLM is communicating based on some standards. I mean, it's only going to communicate within a certain box or frame. You can't go too far left, too far right. There are
Nope.
certain alerts, certain recommendations it's giving.
Yep. And then we utilize so that our large language model is utilizing up to date information. We have retrieval-augmented generation that we utilize when generating mitigations or compensating controls that we're suggesting, or generating attack paths and step information, and how a hacker would utilize XYZ tool in order to compromise a device.
If you're a hiring manager and you appreciate the unique skill sets required to build AI solutions, then I would highly suggest you get your hands on our AI talent salary guide. As you know, one of the greatest challenges in building AI products is acquiring the right team. Over 100 plus pages, we dive deep into our global AI talent acquisition strategies. And with our networks in Latin America, We also provide you with actionable advice on how you can scale up your AI team cost efficiently. Once you explore our AI talent acquisition strategies, you'll never look at hiring the same way again. Links are in the description.
Yeah. How do you think about, or how did you think about, because now we have this issue where if you're using ChatGPT, all the prompts get stored. And even if ChatGPT is not training its own model on the data that's coming in, the government still has access to the data if they want, right? But you have some
Right.
organizations that are saying, hey, I don't even want the government having access, and I don't even want, some of them even say, I don't even want AI touching certain data. How do you handle that scenario in the context that you're working with LLMs?
Yeah, so the platform is entirely on premise. There's no outbound communication. It's not a wrapper around Anthropic or OpenAI. So we actually have local large language models. They're smaller. They're 8
Right.
billion parameter models, but they're local and we run on, on top of two or three, GPUs that are just, regular size GPUs like an L40S data center GPU. And all the data is just there. It doesn't go anywhere. We have some telemetry where, like, in our platform, much like in ChatGPT, you can like thumbs up and thumbs down, like a
Uh-huh.
response, and like give a reason. We have that, and we can collect telemetry that way, anonymized telemetry, to train a new model to utilize like direct performance optimization or something like that in order to help out the prompts and the results. But everything is all local, so we don't even need to worry about regulation.
Yeah, that's actually an interesting space that I've recently been tapping into. So it's interesting that you guys are already on top of that, right? Because, I'm thinking about organizations that are like public sector, you've got PII from like student data, you've got
Yep.
health records, and these are all organizations that want to be able to use AI. But a lot of them are just afraid because they don't want to be sending their data to a cloud model, right? So the
Right.
idea that, all right, if I'm sending this to an LLM, I can actually use a local model, right? Now, in your experience, has there been then, so if I'm saying, okay, great, you're using LLMs, but this one is local, 8 billion parameters, let's just assume that I know what that actually means, right? As an industry buyer, right? Versus the trillions that are used on the LLMs coming from, the Anthropics, the Open AIs. Is there a trade-off on hallucination that anyone should be concerned about?
So we fine tuned our LLMs, our local LLMs, for very task specific use cases. So if you had to put up, let's say, I mean, GPT-5 just came out. If you put
Mhm.
up GPT-5 against Frenos on something task specific, Frenos Syra will always win out because we had to make it that way.
Mhm.
So the trade off is if I was to do this again, or if I wasn't part of Frenos, for the people listening out there, is the time it takes to fine tune and understand the exact task you want your LLM to perform, and then curating that data set, whether synthetic data set or being able to generate real data for it, so that it will always beat out these larger, like super large. I mean, I think GPT-5 is like what, 405 billion parameters, something like that. Like they're huge. They're huge. And like in order to run our platform locally, like you would have to, if we were utilizing like a, let's say a private version of GPT-5, like we would
Right.
need a whole data center in order to run that.
Mhm. Yeah, yeah, interesting. There was a statistic I came across that was saying if, GPT OSS, I think the 20 billion parameter model, if you give it tools, it is equivalent to running, it's equivalent to O3, right?
Yeah, that
Um,
makes sense.
which was interesting. Now, I can't validate that's actually the truth. That may just be OpenAI saying
Yeah,
that.
yeah, yeah. I mean, yeah.
But let's assume you give it tools, it's equivalent to O3, right? To your point, now if you add fine tuning on top of that, right? You're saying I could have something that's better than O3, and haven't really seen better than O3 until probably like 5 days ago. If you think ChatGPT 5 is better. So you think
Yep.
about like the quality of the output that you're getting from the LLM can be just as good or better running it on a local model versus, someone who's saying, okay, well, I can just run all my data through Chat GPT, the cloud model version, because I don't have PI.
The benefit of utilizing ChatGPT, the cloud version, is that general knowledge is there. Like you can ask that, you can ask ChatGPT anything from therapy questions to, questions about your attorney and all that stuff, and it will
Mhm.
still be able to produce an output. Now, when you get to your local models, your open source models, and training those and fine tuning those for a task, it loses the ability for you to ask all those other questions. Because
Mm.
what you're doing is reformatting kind of the brain, the synapses, right? Reconnecting them in a certain way that allows you to excel at that specific task.
Yeah. What I understand, and I would love to hear your perspective from a Frenos perspective, is if you're using local models, the key, or I'd say you get the most ROI when one, you're working with data that you absolutely don't want to send to a cloud model. And or two, right, you could be using a cloud model, but the number of API calls that you would be making to the cloud model would just make this incredibly expensive.
It'd be so expensive. Like if we had to call an API for every time we needed our LLM to operate, like let's just say we did utilize ourselves as like a GPT wrapper or something like that.
Mhm.
I mean, you're looking at tens of thousands of dollars a month just in API calls, just to get what data, and we do this at a fraction of that cost for with a local LLM.
Yeah, yeah. And it sounds like, to me, you all are I mean, first of all, LLMs are new, right? So folks are like, wow, I could use ChatGPT. Incredible that I can kind of put the power of an LLM into my suite of products or a vendor that I'm working with. What I
Yeah,
think scared a lot of people off is right, like where does regulation go? Hopefully soon here, right? More folks will understand. Well, actually, you can still leverage LLMs by using local models. So if you are working for, if you do have one of those use cases where local models makes more sense, now you can still tap into the power of LLMs. Happy to have you comment on that. But the other thing I was also curious about, though, is like, all right, so ChatGPT, like you mentioned, the cloud version, they're adding all of this other stuff that makes it easier to use. When you have a local model, you kind of, I think synapses is, you broke the synapses and you're reconnecting them. So ChatGPT, the cloud model, has an ability to call tools that's going to allow it to give you the right nuance. You don't have that with the local models. Do you have to then, if you're using that, go find someone who understands like APIs, right? And how to use the LLM to actually call tools? And I might be getting beyond my skis.
yeah. You do. So if you go down that local LLM route, right, to adhere to regulations or whatnot, you are going to need a software developer or two to help you with building the model context protocol, MCP. I don't know if you're familiar
Mhm.
with that.
MCP. Yep.
Anthropic came out with a standard, and now it's pretty much being used by everybody. Now you're going to need somebody to help build whatever MCP server you want to utilize for whatever use case, whatever those tools may look like. And then you're going to need to build some sort of wrapper around your local LLM so that you can ask it questions and then it can go and talk to the tools that it has available to itself.
Yeah. The reason I asked that question is you've got folks who are constantly thinking through this buy or build decision. So they may hear, oh, Frenos, okay, I hear what you're saying and from a cybersecurity perspective, but you're telling me that, I can't use the cloud, right? But I can just go get a local model and, you got an internal dev team, but just kind of I wanted to break down a little bit more what's involved in actually, creating the product. And, from your perspective, as you have conversations with the folks you work with, what are the key determining factors between like, hey, let's try to build this in-house, or what, or maybe we should actually work with Frenos. I'm seeing that a lot. Folks kind of seeing a solution and thinking, is this too doesn't seem too difficult. We could spend like 6 months and build this, but we'd love to get your perspective on okay, if you do that, here are the other things that you're going to need to consider, and here's where we position ourselves.
Yeah, so one thing about the Frenos platform itself, and we'll take that question from this specific use case, right? Buy or build. Are we going to buy the Frenos platform? Or are we going to build one? One problem you'll run into is speed of which the LLMs respond. Now we're talking about local large language models, right? We'll say cloud is not even an option.
Mm-hmm.
You are limited by the size of the model and the type of graphics cards you're utilizing in order to get that inference. Now you could, and I actually just read an Arvix white paper about it, somebody utilizing AI agents, just pure AI agents, to build attack path chaining and whatnot. That's great. That's awesome. You know, they can have a planner agent, you can have an attacker agent, a defender, you can do a lot of things. The problem that you run into then is speed. How much information do you want going to your user or to yourself as the company who's deciding whether to buy or build, right? How quickly do you need that information? If you're okay waiting, we'll say, you know, a day or 2 days for some results to start working on it, that full large language model AI agent only approach would work. Now, what we found is that our customers want time to value in less than an hour. So when you approach it from that time constraint, from the time from when you ingest data inside the Frenos platform to when you can start acting on it is less than an hour, then you need to start making some adjustments. So it's not only a large language model that we're utilizing other types of neural networks or other types of machine learning models that has the speed to determine the calculation, but it doesn't need all the intelligence to determine how the step operates or how that particular technique or hacker technique can be utilized. So then we're only calling inference to our LLMs once or twice an attack path rather than for every little decision. And that's where a lot of people that are going down the build route will fall into. They'll get themselves a good proof of concept that gets exactly what they want. But the problem that they'll run into is scalability. And if you're not building your platform from the beginning, saying this needs to scale, you're going to run into this issue after your proof of concept phase. And then you're going to need to re-architect everything all over again.
Interesting. I'm curious about, from a talent perspective, a lot of the technologies we are talking about are new. Absolutely. Well, new is newer than, hey, we just need a front end or a back end developer.
Yep.
MCP is new, so you need to know about MCP servers. Local LLMs, that's new, right? So you need to know something about that. Fine tuning a model, right? So as you thought about building out the company, I'm curious what specific types of talent required. What specific skill sets, if we haven't touched on that yet?
So, software developers are software developers. That's easy, right? Do they match by tech stack? That's fine. AI engineers were a little bit different. You have AI engineers that are like PhD candidates or postdoctorate that have achieved their PhDs. Those are great individuals from my perspective for research and development. Not exactly pushing production code, but research and development, that's what you want them for. What we had to spend time on finding our senior AI engineers was, have they done at least a little bit of what I'm about to ask them to do beyond school, right?
Okay.
That was one thing. And the other thing was, I care more about like the uptake on new knowledge than I care about you actually having the knowledge. So if I give you, a list of white papers and ask you to read them and summarize them to me, are you going to get it done this week or are you going to get it done in a month? If you get it done this week, you're the guy I want to talk to.
Yeah. That's a great point. One, because the world we live in, like, you don't have the luxury of going through a structured program to learn these new techniques, right?
Right.
Not too long ago, Anthropic announced what an MCP is, right? So if you're waiting to go to school to
You're
figure out,
behind.
you're behind. You're behind, right? And so, like, learning how to learn in this world of AI is interesting. Now, you mentioned, have you done something similar to what we are trying to do now, but outside of the academic context? What does that look like when we're talking about AI engineers?
Yeah,
Like,
so we'll take the perspective of like implementing a retrieval augmented generation. If you have implemented a RAG, like we needed to implement a RAG system back in the day. If you had implemented a RAG system at least once and have gone through the pain points and know, where the pitfalls are when implementing the RAG system, like I would talk to you. Or like we have a split in our AI team. We have the AI engineers that are solely focused on large language models, and then we have the AI engineers that are solely focused on machine learning traditional models. You're right. If I am hiring for like that machine learning type engineer, my question to you would be, if you had to develop synthetic data, how would you go about it? Right? These are, if you're asking these types of questions, because like I've lived through it, like I've had to develop synthetic data in order to achieve my outcome, right? And if you're asking the right questions, you'd be able to suss out and identify the right candidate to be able to fill that spot. Now, I'm going to caveat, not all AI engineers are all AI engineers. Like, there's the reason why in our team we have LLM specialists and machine learning specialists, because they're completely different types of technologies.
Yeah, which is interesting because yeah, you've really got, if that's an LLM specialist, I mean, they may have seen I guess one cycle of putting an LLM into production, seeing how it works, making
Yeah.
fixes. So it starts to make more sense where you're like, I need to see some semblance of you've actually tried something. Would you also include like personal projects, building a rag as a personal project into that definition, or is it more so in something that was actually a product for a company?
I would. Personal projects are good. The one thing, the caveat of personal projects is you had to have submitted your code to like GitHub, and it has to be like, needs to be viewable by somebody. Because at that point, right, you have your personal project. At that point, I'm checking you for code quality on top
Yeah.
of the knowledge that you already have. And sometimes like machine learning models, like creating them, you'll have like a Python, Jupyter notebook or something like that, and that will have all your, at that point it's like, put in all the comments and tell me the reason why you're doing certain things.
Interesting. And then you touched on RAG, right? So if we think of RAG, I mean, I think you can kind of consider what an MCP does as RAG,
Mm-hmm.
but it can also go deeper if you're talking about proprietary data. When you all
Yeah.
think RAG, because you did mention you have that inside of your product suite, what does it like mean for you, or how should we be thinking about what RAG means for Frenos?
So the way I think about it is like training large language models, there's a cutoff date to knowledge.
Mhm.
You want to add more data into that model, you have to train it with more newer, fresh data. That is not possible when you're deploying production systems. You cannot always have a new LLM trained every single day on the newest data from the last 24 hours. That's impossible. So what we did instead of that is we have a large language model that we fine-tuned for task-specific reasons. And then we have supplement data inside a retrieval-augmented generation vector database that we can do semantic searching for. So at that point, then we're no longer needing to update the AI model. We just need to update the vector database. As long as the vector database is being updated with the latest information, then the large language model has the latest information to do its inference. It kind of cuts down like the expensiveness that it takes to train a large language model, and it makes it a lot easier when we're deployed on premise to 100 customers, so on and so forth. Being able to update a vector database is a lot easier than downloading a brand new AI model and launching it.
Yeah, and given that you're in the cybersecurity space, have you found that it was necessary to have talent that also understands cybersecurity data in order for them
Yes.
to work for you? Okay.
Yes, 100%. I've worked with other AI candidates that had no understanding of cybersecurity data, and it made the task like 10 times harder for them because not only do they need to perform exploratory data analysis and understand the type of data they have, they also have to decipher what this data means. So that's why it was easier for us to find a, almost like a cybersecurity engineer that so happens to know AI
Right.
versus AI who knows cybersecurity.
Yeah, that's interesting. But yeah, I often see that is the case because the data becomes so incredibly important.
Right.
Another question for you related to the local models. You mentioned that you all were using an 8 billion parameter local model. I think there's another one that's out there, 120 billion. But the main question is there like really a difference or a necessity to be using one that's 120 billion? Or can you, obviously we can do with eight, right? But like, is there a
Yeah,
necessity
it
to be using
yeah,
something?
so it really depends on how much general knowledge you need your large language model to have inside of
Okay.
itself compared to the speed of the inference. So the reason why we use an 8 billion parameter model and we have actually smaller models that do like summaries that are 1 billion parameters
Mhm.
is because we need speed. It's a lot easier to load an 8 billion parameter model into a GPU, execute the inference, and unload it than it is to load a 120 billion parameter model into a GPU. There's that. And also, like, part of our edge case is this is like edge computing. So we need to be able to run on commodity hardware. Some of our customers don't even know how to spell GPU sometimes. So, like, you have to educate them, and they don't always want to buy that $10,000 data center GPU in order to run the platform. Sometimes they want to buy a 4090 or a 5090, right? Those consumer grade GPUs in order to run it. So
Mhm.
we've made ourselves flexible to the type of customers we're operating with. Now, that 120 billion parameter model, what that is really good at is huge general knowledge multitasks, and you would be able to fine tune it in more than just one simple task. You can fine tune in multiple different types of tasks and have it still be able to execute, properly.
Yeah, that insight is, I think it's good because like in a lot of cases within AI, you just hear about like just a massive spending. Hey, we raised billions of dollars and we're just gonna
Yeah,
just gonna throw money at the solution. But people don't think of this actually costs.
it costs a lot of money. I mean, for us to train our first AI model, just trial and error was close to $400,000. Just trial and error. That's not even the production model that we ended up training.
Yeah, I was watching it was like I think it came across my Instagram feed and someone's like, if I'm not mistaken, the platform they're building is a vibe coding platform. And so, you know, in their case, I think the founder was like, are you kidding? Did we really spend $140,000 in API calls to Claude Code, right?
Yep.
And in a lot of cases, I think folks who are just used to software, traditional software, don't think about the added element of API calls. But like in your case, you're actually doing training, which isn't even it's an additional cost. Now that additional
Yeah.
cost for training gives you a more powerful solution, which justifies it, right? But
Right.
interesting dynamic.
Yeah. The training itself is not for the faint of heart. I would not wish it on my worst enemy. That's how involved it is. It's very involved. You're monitoring it constantly, and it takes time. It's like watching paint dry.
Yeah. How would, I'm curious about your fundraising journey and how has that been? Have investors generally been educated on, the different dynamics, the different hurdles that an AI native startup would have to jump over relative to traditional software? And have you found that you have to kind of explain these types of things?
I mean, all investors are different, but what I found generally is now in 2025, they're way more educated. they're actually asking you the right questions. As far if I were to pitch them, they would ask me the right questions. And these investors are also trying to suss out whether you're just a chat GPT wrapper or
Right.
actually an AI native tool. And that there's a big difference, because if you're a wrapper, you're not defensible. Somebody could, vibe code your platform in a weekend and take all of your customers. But if you're an AI native company that have actually put the work behind how to utilize AI properly in a way that's scalable, now you have a defensible moat. Now investors want to talk to you.
Yeah, yeah. I'm glad we got a chance to talk about Frenos. I think you guys are unique, at least on this show, in terms of just talking about the value of local models. All the conversations out there are about cloud models, how to leverage cloud models, and less conversation around local models and use cases and pros and cons and whatnot. So, you guys are in an interesting space. So I appreciate you sharing the detail, because I feel like it's going to be educational, not just to, folks who are on the development side, but also folks who are on the industry side, where they're saying, well, how does this apply to us? And does this open us up to this world of AI that we're hearing so much about?
Yeah, definitely.
I know we're coming up on time here, but I definitely want to leave a few minutes, if there's anything we should be keeping an eye out for, anything that you wanted to announce related to Frenos, the floor is yours.
Oh man, putting me on the spot. Anything to keep an eye out. I'm gonna do a prediction. And my prediction is, in the next 2 years, I think transformer based large language models are not going to be a thing anymore. Somebody's going to come out with a better architecture that is going to be proven, that will supersede all of what we've been working with. And they would be able to build a smaller model that is much better than these large language models, the super giant ones. That's my prediction. That's what I'm going to leave your audience with.
All right, all right. Well, when we upload, we'll be able to track. But I'll say, amusing thing about because ChatGPT 5 came out, what was it, last week, right?
Yep.
And everyone thought it was going to be this generational shift in AI expectation.
It's not.
And the reality is that people are like, give me 4.0 back, give me 0.3 back, which is insane.
Yep.
Which is insane.
I mean, if you look at it, GPT-5 is basically, it looks kind of like a router to the other large language models that they have in the background to choose which specific tasks. See, this is the reason why I say that the current transformer based architecture of large language models isn't going to survive. You need a new. We've had transformer based architecture for the past 7 years now, 8 years now.
Mhm.
There needs to be something else developed in order for us to continue following Moore's law and being able to execute AI appropriately.
And to add to that, I find that user experience is going to become more important, because I'm using ChatGPT 5 and I'm just trusting that it's routing me to the right model. I don't
Yep.
know that it actually is. So what if I'm paying up to use a more expensive version and they're sending me to something that costs them less so they can eke out more margin? That's kind of and if I notice that based on the output, that creates this kind of fight between the model provider and the user.
Yeah, and that's what you're going to run into with these companies that their whole focus is foundational models, is that eventually they need to start turning a profit. There's going to be a point where push comes to shove, they're going to need to make some changes to how the models operate or how the API operates, either charge you more or figure out a way to do it less.
Yeah, yeah. Which people will come calling you saying, "Hey, can you talk a little bit more about that local model stuff?"
Yep, exactly.
Awesome. Well, no, this was great, Harry. I learned a lot. I'm sure other folks learned a lot as well. So I appreciate you just being an open book here and sharing your experiences and the things that you've learned in the process of not just building Frenos, but your experience prior to that as well.
Yeah, no worries. Thanks for having me.